Chemistry Chapter 7 Modern Periodic Table. Let us today study modern periodic table. The physical and chemical properties of elements are periodic function of their atomic numbers. Structure of the modern periodic table. Take a look at this periodic table. The modern periodic table has horizontal rows intersecting the vertical columns, giving rise to a number of boxes. The horizontal rows are called periods and the vertical columns are called groups. There are 7 periods numbered 1 to 7 and 18 groups numbered 1 to 18. In the modern periodic table, the overall shape of the modern periodic table shows that it is divided into 4 blocks. 2 groups on left form the S block, 6 groups on the right constitute the P block, 10 groups in the center form the D block, and the 2 series at the bottom constitute the F block. International Union of Pure and Applied Chemistry IUPAC symbols of all the 118 elements. Block-wise characteristics of elements. The elemental properties are characteristics of the block they belong. Characteristics of S block elements. The S block contains the elements of group 1, alkali metals, and group 2, alkaline earth metals. All these elements are reactive metals and occur in nature only in combined states. Characteristics of P block. The P block elements together with S block elements are called main group elements or representative elements. The 18th group is the family of noble inert gases. The P block contains all the 3 traditional types of elements. Characteristics of D block elements. The D block contains elements of group 3 to group 12. They are all metals. The D block elements are known as transition elements or transition metals. Characteristics of F block elements. The F block contains elements all of which are metals and are placed in 2 rows called lanthanide series and actinide series. All the transuranium elements are man-made and radioactive. Periodic trends in elemental properties. These trends are explained in terms of 2 fundamental factors, namely attraction of extranuclear electrons towards the nuclei and repulsion between electrons belonging to the same atom. This results in 2 interrelated phenomena called effective nuclear charge and screening effect. The inner electrons shield the outer electrons and the nucleus to a certain extent. This effect of the inner electrons on the outer electrons is called
screening effect or shielding effect of the inner or core electrons.
The effective nuclear charge felt by the outer electrons decreases largely down a group. Periodic trends in physical properties. The periodic trends in physical properties with reference to atomic radius, ionic radius, ionization enthalpy, electron gain enthalpy, and electronegativity. Atomic radius. In the case of nonmetals, except noble gases, the atoms of an element are bonded to each other by covalent bonds. Ionic radius. An atom forms a
positively charged ion, cation.
On the removal of 1 or more electrons, where a negatively charged ion or anion is formed with the gain of 1 or more electrons. Ionization enthalpy. The energy required to remove an electron from the isolated gaseous atom in its ground state is called ionization enthalpy. Electron gain enthalpy. The enthalpy change that takes place when an electron is added to an isolated gaseous atom in its ground state is called the electron gain enthalpy. Electronegativity. The ability of a covalently bonded atom to attract the shared electrons towards itself is called electronegativity. Periodic trends in chemical properties. This property is numerically expressed in terms of valency or valence. Periodic trends in valency. The periodic trends in valency of main group elements by taking examples of hydrides and some oxides. Periodic trends in
metallic and non-metallic character.
Metals are characterized by good electrical conductivity and ability to form compounds by loss of valence electrons. Metallic characters decreases across a period. Non-metallic character increases across the period and decreases down the group. Periodic trends in chemical reactivity. Chemical reactivity of elements is decided by how easily it attains electronic configuration of the nearest inert gas by gaining or losing electrons. That is all in this chapter. Thank you.